Thank you. So we're going to calculate frequency and wavelength today. Let's start off with an analogy. Let's imagine a train.
We're drawing this?
Yeah, you can draw this. It's a train. It's going to need wheels on both cars. We'll make it an on train, one smokestacks, right? Okay. It's a really plain, boring looking train.
I think it's nice.
Well, let's imagine that one of you is standing here. And you watch the train cars go by. Right? And let's say 3 cars pass you every second. Right? 3 cars per second. And let's say the length of each train car, let's say I assume they're all the same. The length of each car is, I don't know, let's say 20 feet. So this will be like number of cars. This will be the length of each car. Okay, so 3 cars pass you every second, and each car is 20 feet long. Can we calculate how fast the train is going? Yeah, how fast is it going?
60.
Yeah, 60 feet per second, right? Because it's going to be the speed of the train is just going to be the number of cars times how long they are. It's kind of common sense if you think about it. 60 feet of train passes you per second, so the train must be going 60 feet per second. It's the same thing when we're calculating the speed of a wave. If we take the number of waves per second, which is frequency, and the length of each wave, which we have is lambda, when we multiply those two together, f times lambda, that gives us the speed of the wave. We're not going to use s for speed, we're going to use c. I'll tell you in a minute why. So that's it. Number of waves times the length of the wave gives you the speed of the wave. And this is true for all waves. For electromagnetic waves, we equal it to c because the speed is always constant. Good so far? Yes. Wonderful. Now let's do some math. All right, so first off, I got to give you, actually, let's take that equation here and let's list what everything is so we know, you'll have it in your notes. You know, F is frequency. Lambda is wavelength. And then C is the speed, but it's a constant, right? So, C, and it's the speed of light. Okay. Just remember, light is an electromagnetic wave, and so that and all the other waves, they all have the same speed, which is 300 million meters per second. The reason I'm giving it to you in meters per second is because I'm going to give you wavelength in meters, and so it'll make the math really simple.
C equals that?
C equals that, 300 million meters per second, or 3 times 10 to the 8 if you prefer. All right, so now we can do some problems.
Wait, what is S?
Seconds, meters per second. All right, so let's do a couple problems. So what is the frequency of an EM wave? Has to be an electromagnetic wave, right? If it was a sound wave, we'd have a different C. It would be the speed of sound, something like that. So what's the frequency of an EM wave with a 2.6 meter wavelength? And understand most of the ways we deal with are smaller than a meter. I'm trying to keep the math simple here. All right, so we list our givens. Lambda is 2.6 meters. C is 300 million meters per second. And frequency, that's the thing we're looking for. So you just write your equation down. F times lambda equals C. And we have to solve for F, so what do we do? Divide both sides by lambda. So F equals the speed over the wavelength. So now we're just plugging in numbers. 300 million meters per second. Don't worry about the per second, just ignore it, write it in there, but ignore it. Divided by 2.6 meters. The meters obviously are going to go away. 3 divided by 2.6, it's going to be like 1.1 something. Right? Somebody plug it in, tell me what you get. It should be like 100 or something million.
The 15,384, 615.3.
First three are 115.
Yeah.
I'll just put zeros for this. So 115 million per second. The seconds is still there. And that makes sense because remember, I told you frequency is the number of something per second. In this case, it's the number of waves per second. So you should always have per second or hertz as your units. They mean the same thing. And I guess you should write this down too. So people who write stuff a lot in books, they don't like to have fractions. So instead of having per second, they came up with a unit that means per second, and it's called hertz. It's irritating. It just means 1 over a second. That's what hertz is. So these two are the same thing. So I don't care if you write your answer as 115 million per second or if you write 115 million per second. All right, let's do one more problem. Should I do another one where we calculate frequency, or are we good with that? Okay, so let's do one where we calculate wavelength. So let's say a wave, assume it's an electromagnetic wave, and a frequency now let's see.
Yeah.
Yes.
Hertz always meters per second.
Hertz is just per second. Nothing per second. 1 over a second.
Turn it off per second.
Hertz just means per second. Okay, so we have a wave with a frequency of, I don't know, let's say 1.2, let's say billion per second, or hertz. Well, let's write hertz because that's cleaner. Whatever. What is the wavelength? So our F is this number here. Do you like it like this, or do you want scientific notation? Good. Okay. So 1, 2, 0, 0, 0, 0, 0, 0, 0, 0. Hertz or per second. I'm going to write it per second in the calculation so that you can have the seconds canceled. And then C is C. C is 300 million no matter what. Meters per second. All right. Let's make some. Does everybody have this one down? Can I erase this?
Mm-hmm.
All right. Okay, so now we got to calculate lambda, right? How do we solve for lambda? Yeah, divide both sides by F. F cancels, we got lambda equals C over F. So really, whichever one we're looking for, we're doing C divided by that thing. By the other one, rather. So lambda equals 300 million meters per second divided by 1.2 billion per second. Which means cycles per second, and waves per second, waves per second. So the per second is on top and bottom, that cancels. So our answer is going to be in meters. 3 divided by 12 is 0.25, right?
Yeah.
I mean, there's just a bunch of zeros.
Wait, so are you dividing it 300?
300 million divided by 1.2 billion. Yeah. I mean, you don't, you can plug it into a calculator, but you can save some time by crossing off some zeros, right? It's really 3 divided by 12 is what that comes out to. So, 0.25 meters. All right. Questions? Anything wrong with it? We're good?